So chapter 5 is all about the periodic table of elements. We skipped chapter 4 for now because it's a little bit of a difficult chapter to teach virtually, but this is a pretty easy chapter, just content, so you should be fine with this one. So there are multiple parts of this chapter. So we're going to start with part 1. Here's a little chemistry joke for you with Chemistry Cat. Suits the chapter. Maybe made you laugh or smile. Maybe not. Okay, I'm going to skip the video just because it's just an introduction. So part 1 is the history of the periodic table. And this part is pretty brief because I just want to give you the most important parts about the history of this very complex and important table. So some of our known elements, such as copper, silver, gold, these have been around since prehistoric times. They've always existed on our Earth since Earth was made, in whichever method you want to prefer, saying it's been made. However, some elements had to be discovered because you couldn't just mine for them or find them easily. So an element was defined officially in the 1700s by Robert Boyle. So until he coined the word element, they just called it copper, silver, gold. He made the word element a thing, and that's what we just refer to our elements. So in the 1800s, specifically 1800, 30 elements had been identified, meaning that they'd been discovered and categorized and classified. In 1870, we were up to 60 elements that had been identified. So we're getting more and more elements identified. So now we need a way to organize them for all scientists to be able to access this information. So the question was, how do we want to organize them? Well, Dmitry Mendeleev came to the rescue. So you don't need to write this in your notes, but basically Dmitry Mendeleev took all of our known 60 elements at the time he was doing this and put them on note cards, kind of like index cards. And he wrote down their name, the properties that they knew, and the atomic mass. And he began to sort them. So he created the first periodic table, and it was published in 1869 with these 60 known elements. And he decided that the best arrangement would be by increasing atomic mass. And when he did the increasing atomic mass, he also realized that they kind of sorted into categories by similar properties as well. An interesting thing that he did was he actually left empty spaces for elements that had not yet been discovered, but because of his organization, he was able to predict their properties and say, well, if this exists and if this exists, I think there's an element in between there that would fit in. And actually, he was correct. So this is what his first periodic table looked like. It's in a different language. So that's why you don't recognize some of the writing, but the numbers and the symbols are somewhat similar. So we have hydrogen with a mass of 1, lithium with a mass of about 7, that's correct, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So he sorted them by mass and he left empty spaces. So now we know helium is in between here. And he just left some empty spaces for elements that he thought would fit in. And then he also had some that had some question marks, but it doesn't look exactly like our periodic table, but he was off to a very good start. So he also came up with a periodic law that basically said the physical and chemical properties of elements are periodic functions, which means repetitive, of their atomic number. That's going to be helpful for the next guy. So 40 years later, Henry Moseley was using Dmitry Mendeleev's periodic table, and more elements have now been known. And he decided, why don't I arrange the elements not by increasing atomic mass, but by increasing atomic number? Because remember, the atomic number is unique to every single element. There's only one element that has one proton. That's hydrogen's atomic number, 1. There's only one element that has 2 protons. That's helium, atomic number 2. So when he took atomic number into play, he realized that the table fell into even greater order, and the elements with similar properties and similar groups had an even more accurate order. But we had to have Mendeleev to get the ball rolling. So our modern periodic table, if you're looking at your periodic table, you're going to need it out for this chapter. We follow Moseley's arrangement. So we start with hydrogen number 1, atomic number 1, and then helium number 2, and then lithium number 3, and so forth and so on. None of those numbers are repetitive. So we refer to the vertical columns up and down as groups. We already talked about this in a previous chapter, and they're numbered 1 to 18. And then we refer to the horizontal rows side to side across as periods, and they're numbered 1 to 7. And remember, I said the bottom of the periodic table, that's not period 8 and 9. Those rows actually fit into the periodic table, which we will talk about later in this chapter more exclusively. So in addition to there being group numbers, group 1, group 2, group 3, we can also say that there are families of elements, because when Moseley rearranged the elements, they were grouped up and down as well by characteristics and properties they had. So there is a group 1, but that group 1 also has a family name, which will be the next part of the chapter.